It's like chapter 7 and 8.
Okay, so are we starting with
Yes.
maybe I start going to chapter
Okay. Oh.
So, chapter 8. So for chapter 7, in chapter 7 we're looking for drawing the moment diagram and shear force diagram to a bar, like let's say, and there's a force or some distributed loads. We are able to find the moment at any point of the bar. That's what we did in chapter 7. Are you guys okay with chapter 7? Yes. From chapter 7, we can look for the shear force, which is B, and the moment B at any point of the bar. That's chapter 7. And in chapter 8, we need to find the stress in any plane of the bar. So let's say if you're okay with chapter 7, you are able to find any moment of the bar, and then let's say when there is a bar like this. So when there is a force here, and there will be a moment coming down, and this bar will look like this. So there is moment at any point of the bar, because moment is just f times distance, where any point, let's say this point, I have to look for the moment at this point, this will be a distance. And after we get the moment at this plane, let's cut it through, and let's say this is the cross section up here. And now in chapter 8, we are focusing on finding the stress at any point of the cross section. Can you imagine this? It's like this is the bar, and when there is a force coming at here, the book curves like this. And so if I cut one section, if I cut through here, there is stress at any point of the cross section. And in chapter 8, we are looking for the stress at any point of the cross section. So for the cross section, this is the cross section. Okay, this is the equation for looking for the stress in the cross section. So we mentioned just now that we're able to find a moment at any point of the bar. So this is basically just a moment at that cross section. At the same cross section, the moment is going to be the same. And to find this, you need to find the I, which is the second moment of inertia. I here, I is just I for a square is just 1 over 12 dh cubed for a square. Or rectangle is just 1 over 12 dh cubed. Where B is this one, the base, and H is this. Okay. This is I squared Z. Is z-axis. If you are looking for I squared y-axis, it's just 1 over 12 h cubed. Just like turning. And Now after we find um, the moment of inertia, we got this one, we got a moment, and now we need to find the y. I just kind of like go too fast. Tell me if you got any confusion. So the y is just basically the distance. Let's say if I know the centroid of this, let's say this is the centroid. It's in the middle, h over 2. H over 2. The y is just basically any point. Let's say I want to find the stress at this point. The y is just the distance between here to here, from the centroid to the point that I want to measure the stress at. Let's say I want to find for this point, this is the y. If I want to look for a stress at this point, this would be the y.
Would it make a difference if it's like the Z after
I mean for this,
the Y?
for the y. Okay, you mean when we are looking for this axis or this axis? Okay, because I'll go through a different example and see that. Let's say it depends on how you curve the beam. Let's say if we are curving at this point, the y is, if this thing is curving out here, the distance, the y is this. If you're I get it. If this is so when this is curving here, we're looking for the y distance here. When this is curving here, we're looking for yeah.
You just look for
Yeah. Sorry.
Just like
Yeah, I actually,
okay.
I remember getting that kind of question. So maybe I'll just go through, I'll just do the first and but so we talk about the y distance. So are you able to find for the talk about this slide? Okay. So for chapter 8, the basic thing you need to know is the first thing you need to find the centroid if it's not given. So everyone know how to find the centroid for any shape? Okay, I'll just go. Okay, I'll go through how to find the centroid. Let's say. So this is a T shape here, and here is E, So to find the centroid, basically the equation is just a summation of a I over the total area. So let's look at this shape. So for this shape, we can cut this into two parts, part 1 and part 2. For part 1, the A is just h times b, and the y is just the distance of. We know the middle of this is going to be here, right? Which is h over 2, and the y is just the distance from the bottom to the middle, to the center of this part, which is the middle. So the total distance here is just b plus h over 2. Here at this part, the distance from the bottom part to the center of this part. And here is b, and the middle of here, the height is h over 2. So the total height is b plus h over 2. So b plus h over 2. And the second part is here. The second part, the area is still h times b. And the height to the center of the second part is just b over 2. Because the total height is b, and the height to the middle part is b over 2. So here we go, b over 2. This is the numerator, and the denominator is the total area, which is b times h for the part 1 plus b times h for the part 2. So this is looking for the centroid. So after you get all these numbers, if you plug in a number, you will find out the centroid will be around here, in between 1.1 and 0.2. Okay. This is where we know that the centroid is going to fall on here. This is the shape we talked about just now. We know that the centroid is going to fall around here, which is on this axis, because this part and this part is the same. So we can know that the centroid is going to be here, which is fall on this axis. That's called axis. So we just need to look for the centroid for A1 y1 plus A2 y2 over A1 plus A2. Because we just need to look for the height, which is the y direction, because we know that it's going to fall on the middle. But what if the shape is look like this? So you wouldn't be able to use the equation just now. You will need to add some more things, because you don't know that you couldn't show that the center is going to fall on this axis or any axis, it might fall around here. So now you need to find for the z coordinate and the y coordinate. So if we want to find for the height of this centroid, we can use the same thing, a1 y1 plus a2 y2 divided by the total area, a1 plus a2, where y1, let's say this is 1. Let's say this is 1 and this is 2. y1 is just this one. And y2 is the middle. y2. After we calculate this one, we can find the height of the centroid. Let's say y bar is around here. This height. Y bar. Then we know that the centroid is going to fall on this axis. But now we need to find where the centroid is going to be. It's going to be here, here, or here. So now we need to find a z bar, which is a1 x1 plus a2 x2 divided by a1 plus a2. Okay, so now I'll clear up the y. Now for part 1, the x1 is just going to be the x direction distance to the middle of part 1. And x2 is just going to be here to the middle of part 2, x2. So after you plug in the x1 and x2, you can find the x bar. Let's say x bar is around here. And we found that just now y bar is around here. So with x and y, we can know that center is going to fall at here. So the conclusion is when the shape looks like it's symmetrical, like this, let's say it is symmetrical, you only need to look for the height of the centroid because you know that the centroid is for sure is going to be fall in the middle of the shape. You just need to find how much is the height. But for something that is look like maybe like this, which is not symmetrical, you have to look for the x. You have to look for the height and the x direction. That's how you find the centroid. Okay. With this, this concludes everything for the centroid. Next. So after you calculate the centroid, you will need to find for the moment of inertia. Okay. So for a square like this is h, this is b. The I is just basically 1/12 dh cubed. But for a shape like this, we don't know how to calculate the I for the whole shape, so we have to separate it into 3 parts. Let's say this is part 1, part 2, and part 3. So for each part, the I is going to be, let's say I1 is going to be 1/12 dh cubed. But the centroid is not, the moment of inertia is acting on the centroid here. But for the whole thing, we gotta go below centroid, which is maybe around here. So we need to shift the centroid to here. By this, we have to add in one thing, which is a1 d squared, d1 squared. So the A is just the area of this one, and the D is this distance, which is the center of this to the global centroid, which is the centroid for the whole shape. Hear about this one?
Why do you have to move it?
Okay, because for a shape like this, we don't need to move anything because the second moment of inertia is acting on here, which is the center of this part, which is also the center of this shape. But for here, if we calculate I1 equal to 1/12 dh cubed, it's acting on this line along the center of itself. But we are calculating for the whole shape. We are calculating the moment of inertia which is acting on the centroid of the whole shape, which is here. So we need to shift the centroid to here by using the A1B squared. So let's say the centroid at 2 is same as the global centroid. Then you don't need to move that. It's just I2 is just 1 over 12 BH3. Because let's say the center of 2 is the same height of this, then you will need to move anything. Okay. So but for part 3, you will need to shift the centroid to up to the global centroid. Okay. So this is the first part of the chapter. So and so for the homework, yeah, I think a lot of the previous homework, the previous homework is the previous homework is exactly you need to calculate the largest moment and calculate for the largest stress. Okay, so this when he gave you a bar like this, let's say bar of any force on it, and if he's asking you for the largest bending stress, the first thing you need to do is find the largest bending moment. Because bending stress, remember this, bending stress is over my. Bending stress is my over I, where y and I depends on the cross section. So to find the largest bending stress, we have to find the largest bending moment. To find this, we have to use you can use any you have to draw the moment diagram. Let's say look like this. So the largest bending moment is going to be this point, and you use the moment here and plug in there. So after you get the largest moment, you just need to plug in this m and use what we talked about just now, the my. The y is the distance to, usually it's the top part or the bottom part, the y. So and I, we mentioned about this just now, so you should be able to solve for the I.
So do you do both, like from the top and the bottom, to see which one is larger?
If the shape look like this, let's say if the centroid falls in the middle, the top part and the bottom part is going to be the same. Let's say it's like this. So here y1, here is the centroid, and y2. So if y1 is larger than y2, you can know that here is going to be bigger than here. Yeah. And do you have any problem in drawing the moment diagram? Which method do you use for drawing? Chapter 7? Yeah. So which method do you use? Do you use singularity function? Which method do you use? Okay, so maybe I'll just go through, after I finish this, I'll go through again chapter 7. Because I'll go through the steps and the yeah, because it takes a long time to go through the whole. So maybe I'll just go through this quick and I'll go through the. So now I go through the The last two questions for the coming forward is so this is for the homework that you need to submit this Thursday. So let's say, okay, so there is a force here. When there is a force applied here, you know that for this plane here, let's cut this plane, covering this here. When there is a force applied to here, we know that the force is going to apply to here as well. The force applied to here, just look at there's any small force. So on this plane, the stress is going to be F over A here. But there is also going to be a moment created on this plane because there is a distance here. So when the force applied here, the whole thing will the whole part will bend into this way, so it must look like this. So this is a force because of this force and because of the distance, there's going to be a moment and it will turn it this way. So on this cutting plane, there will be at this part and this part. This part will be in tension and this part will be in compression. Can you see this one? So when I'm pushing it down, this thing is stopped. So this thing is compressed while this part is like bending. So there is tension in here. Okay. So if we need to calculate the stress at, let's say, this point here, stress, we mentioned just now there is one F over A, but there is also one stress for the moment, which is also plus, let's put My over I. The M is just F times the distance, the moment that acts on this plane. And I is just the I for the square. And Y is just the distance from here to here. So the main thing for this is just like, you have to know that when this force is applied here, what will happen to here and what will happen to here. Okay, I'll change to next. So if this is the case here, if my force is applied at one point here, and if I cut it here, okay, so this is my cross section. There will be a force coming down, which is the stress is F over A. And because my force is actually at this point, and there is distance between here and here, so this thing will turn it this way, bending this way, right? So here we also have a tension, and here we have a compression. So let's say this is the box, right? If you are pointing this way, here we have a tension right here, and at this edge we have the compression. So if the question is asking you for the stress at this point, you're using F over A and minus My over I, because F over A is it's plus, I'm sorry, it's plus, because this is coming downward and
because of compression, this is coming downward. But for here is minus because one is coming downward and one is going upward. So let's say for the question. This is the homework question. Let's say there is an F here. So there is an F here, and you have to separate this into two F. One is Fx and one is Fy.
And he's asking you for the stress at this point and this point. That's called the stage and K.
So you can see that Fy is pointing downward, which is pushing the whole bar downward here. So for point H and point K, this is point H. This is point H and this is point K. So for point H and point K, there will be a stress which is Fy over A. Let's put a negative because it's coming downward. There will be a normal stress done by Fy at both points. And there will also be a bending moment done by Fy because this is like going this way, so the whole thing will turn this way. Can you see this one? Everyone can see this because it's important that you can see what is going on there. So when this is pulling downward, the whole thing will be turning this way. So in point H, you will go through a tension. At point K, they will go through a compression. So for point H, there will be a tension by Fy, and for point K, there will be a compression by Fy. Yes, Fy is 3 on both this. And now we look for Fx. The Fx is pulling this way, right? When you pull this thing is still going to be turning this way, right? So it's the same. Fx will cause a tension in point H, tension done by Fx, and a compression done by Fy. A compression done by Fx. So for both Fx and Fy, it did compress of this. For point K, there is compression done by Fx and Fy. For point H, there is tension done by Fx and Fy. This is how it's do the question for the homework. So are you able to is there any more question on how to see how the force react on the plate? Is that okay? So maybe I'll spend the remaining time for the chapter 7. You guys need help in chapter 7, right? Yeah. I'm going to go through chapter 7. You're okay with chapter 7? Maybe you can just do one more second. Okay. For chapter 7, it's basically asking you to draw a shear diagram and a moment diagram. So for chapter 7, you just need to know how to draw the shear diagram and moment diagram. There are 3 methods in the textbook, but I use the singularity method. So I'll go through the singularity method now. Because for me, singularity method is the safest way. You won't make any mistake if you follow the rules. You can use it.
PC. For singularity method, you need to memorize a few things. So the first one is when there is a force, you need to is going to be x minus a to the power of 1. And this is when there is a force. When there is a moment, let's say there is a moment, this is going to be x minus a 2. And when there is a singular force, okay, so when there is a singular force, let's say this is a singular force F, this is the equation F, so here is just a F, and here is x, bracket x minus a. A is the distance from the starting point to the point of the force. So this is F, this is the distance A. So the distance from the starting point to the point of the force is A. And when it's a singular force, the power is -1. So when now I change the singular force to a moment M, I'll just bring in, so it's going to be the same, just the force to change the moment and the power to -2. So it's kind of easy to remember. So when its moment is -2, when its singular force is -1. So when it's a distributed load, look like this, and A is the starting point, the distance to the starting point A. Okay, and now the power is power of 0. Okay, and the next one is when there is a triangular load. So when there is a triangular load, and let's say this distance is B, and this is F. So the triangular load, you need to change this to the gradient of this line. The gradient of this line is just F over B. Right? So the gradient is F over B, and the starting point is A, and the power is 1. So it's very easy to memorize. The first part is what is acting on it. If it's a force, then it's a force. If it's a moment, then it's a moment. If it's a distributed load, then this is a distributed load. And if it's a triangular load, then this is a gradient. So the second thing you need to memorize is just the power. The moment is -2, singular load is -1, and distributed load is 0, and triangular load is 1. So you just need to memorize this part.
Why do you do that symbol?
What symbol? The bracket? Yeah, this is just how they used to do this, because when you are doing this, you are not like solving a normal equation. It's a special type of equation. By that, integrating is a different type of equation too. So it's just kind of simple. Yeah. So now, because it's kind of important to learn this, because We are using this on chapter 10, which the professor is going through now, chapter 10. We are using the same thing, which is singularity function. So it's important to go through this. Okay. So we mentioned about like how to write the Wx just now. For this, let's say this is A. For this, x minus A. So, is this right? Or did I miss anything here? Yeah. Okay. So because for this equation, this needs to be go through all the end here, right? But I don't have this part. So this is basically this one. One go all the way to the end plus something that is coming up at the end, right? This can cancel this part and that is that, right? So for this one, now I just need to plus something, which is this one. Let's say this is E. So I need to add something up here to cancel this part, so that it will show it like this. So this is basically A plus B. Because now my starting point is at this point A plus B and 0. So this is how you do it. So you don't need to memorize so many equations by using this kind of method. And same to
Why is that?
it's negative because my force is coming downward and plus is going upward. Yeah, I did it. So the same thing happened to this one. Let's say this one. So the gradient is h over b, and here is a, and here is c. H over b, x minus a to the power of 1. So the same thing. This is for the whole triangular loop. This equation is for the whole one, right? So now I need to delete this part. I need to cut out this part so that I can get to this one. So now I just need to minus this one. I need to minus this one and this one. So for the rectangular, it's just because here is the same, it's h, right? It's h. So h x minus a plus b. And now it's the power is power of 0 because it's distributed load. The rectangle is a distributed load. And now I cut out this part and I still left with the triangular part. So the triangular part is now starting from a plus b. And now I just need to x minus a plus b to the power of 1. Get this one? Because my triangular is starting from this point right here. So the starting point is a plus b. And the gradient is always going to be the same because it's the same triangle. Yeah, same. The gradient of here is going to be same to the gradient of here. So the gradient can just copy it down.
Oh, yes.
Okay. Yeah. So okay, so let's just try to see
Okay, so if this is a question and you need to draw the moment diagram, the first part you need to do is first you have to draw the free body diagram. So the free body diagram. Let's say this is point C, point B, point C. So the free body diagram is AY, FA, and CY. So the first thing you need to do is draw the free body diagram. Okay, after you draw the free body diagram, the second thing is, the next step is to power draw WX equation. Okay. So for WX, we'll go through it one by one. So the first one, I'll write for MA, the moment. One thing to remember here is at singularity function, the moment clockwise is positive or anti-clockwise is negative. This is different to what you did in the previous chapter. Okay, so now my moment is going to clockwise, so it's positive. And MA and X minus 0. Because the starting point is 0, so my starting point is 0 and the power is negative 2 because it's a moment. And the next thing is AY. AY is X minus 0 to the power of negative 1. Negative 1 because it's a singular force. And the next thing is CY plus CY. So now CY is X minus 2 and the power is negative 1. And we still got one distributed load here. So the distributed load is just omega naught X minus 1 to the power of 0.
Wouldn't it be negative?
Oh yeah, for this one, right? Yeah, I made a mistake. Okay, so no problems at here, right? Everything okay. Okay, so now we need to, the next step we need to do the integration. You notice that you don't know what is MA, you don't know what is AY, and you don't know what is CY. It's not given in a question. You can either solve this through like the sum of force or the sum of moment, or I'll introduce a method of solving this too. Okay. So when I integrate this, I get the shear force. So integrate is just MA X minus 0 1. And I integrate one more term, then I can get a moment.
When you integrate the first time, wouldn't the second term with AY and the third one with CY both be 0?
Yeah, sure, right. This is this will be power of 1. Okay. Everything good at here? Okay. So everyone is okay with the integration part? You know when you need to divide by 2, right? This part is okay, right? Okay.
So the next thing we'll need to
Okay.
So the next thing you will need to do is look for the AY, CY, and FA. Okay, that's so when the bar look like this, I'm just giving an example. So when this is 2 meter, and let's say you have a okay, so what would be the shear force at this point? Anyone know this? What would be the shear force at this point? So there would be no shear force at here because there's nothing at here, right? So there is no shear force, even though this is just like 2.01, there is nothing there. There is no shear force there. So you need to bring in this. Let's say I got my dx equation is x minus 2 okay. So let's say I'm just simply coming off this one. So let's say 2 plus 0.1 is this point. There is no shear force here. So the shear force is going to be 0. And you need to bring this in into
2 minus 0 to the power of 1. And so here 2 is smaller than 3, so then you bring the 2 in here. Do you guys know this rule? Okay, yeah.
Sorry.
Because we have enough time and this need a very long time to going through this one. Are you guys free on Friday? Is that can you guys? Because maybe I'll just go through the singularity function on Friday.
When?
Like the review session is not.
I could come in the morning. Yeah.
Because this really takes a long time to explain. Friday. Next Thursday is the midterm. Oh, what time are you doing?
Like 10 to 11 or anytime before 11.
How about you? Maybe I was gonna, I try to
Next week, do we have low pickup before Thursday?
yeah, sure. I'm going to switch the time to Wednesday, 2 hour time.
I probably won't be able to come down. Not unless it was in the morning. I have like a class all the way till 7.
7:40. I'll start at 6:30, adding to go all the way down to 8:30.
Okay.
Are you guys not sure about the singularity function? Yeah, again, we can set it okay. On Friday review session will be 1 to 2 p.m. Yeah, 1 to 2. And we're going to try to go through this and maybe I'll go through it on the review session. Because the time is too short to go with everything on it.
Thank you.
Or you can check your unit for help, like 8, 9, 7, 8, and then you can yeah. So, but 7 is related to 8 or 9.
I don't know how that's it.
Maybe I'll have two sessions on Friday, like, or should we go to that and already concept, and, I'd like to know, yeah, so, yeah.
Thank you.
Thank you. So我就是学 process 来着，还有学 process 可以推荐的话，然后当我在毕业的时候，你会看到我。这样，然后这样，这样，对，然后如果是按显明的附近，然后跟我对的这个，对的这样的，所以我建议就是1.3，就是 小或者爱的话，我是爱。然后当我爱吃小鱼的时候，我是爱。一个怕就是2可爱，一个怕把它整理出来成一个，你只要它就是不管是正的 X 对，它是这样子，然后到最后的时候，它这样万一这个你非常好，没有别的，我跟你讲，如果这里不是爱看这一件，你要知道的是，你要看它这怎样画，如果是你的 X 是这样，或者是所以然后你整理出来的就是好像如果还可以跟是标本，你不需要它哪一个point可以，因为你用在网上，你不需要它不在哪个point可以，所以这个时候就可以看你所以你就把这个随便把它就可以找到point，你要这样的话，现在能够找到这个。然后这个过后，我们也是一样的方法，而且也知道这个point，这个是我们的这个就是拿出你要这个派的推荐出来，画。然后这画了之后呢，对啊。后面的话就是像是加地方，就是能把这个地方的这个去跟随那个把它变成然后你这个是这种科，你只是看到这个是这样的，对，如果他替我画，今年不一样，不一样少，就是少的菜色号码不一样，就是你们反正如果是 X 对的话，你去来看号码。就是如果你可以看到这里可以跟我们去找他找那个找号码，就是说你说哪个号码？我帮你看看，考试的时候要，这个时候要不过可能这个 point 就不用了，这个 point 你不用这种管，对呀，找，那朋友你这种管，我只会用对，那个。所以，如果你是要算这种point